Hello everybody, so tonight we're going to quickly review for chapter 2. So this is chapter 2 homework review. I will only circle what I think it's important and what I think we'll probably see on our quiz coming up. Okay, so I will post these notes in your Google Classroom as well. I will only think and do what I think it's important. All right, let's quickly start. I'll start with number 3. It says use the given minimum and maximum data entry and the number of classes. Find the class width, the lower class limit. So they pretty much gave you every. And how do we find class width again? I think we do range over number of classes. Remember, you're going to have to round up to the nearest number or nearest whole number. So your range is going to be 69 minus 12 over 7. So 69 minus 12 divided by 7, that gives you 8.14. But remember, you have to round up to the nearest whole number. So this is going to be 9. So my class width is going to be 9. Your lower class limit, remember when you start your frequency distribution table, your lower class limit starts at the minimum, right? You're going to start at your minimum and then you end at your maximum right here. So you have 7 classes. You're going to start at 12. Okay, and then you increase by 9 class width. So 12 plus 9, that's 21. Then plus 9, that's 30. Plus 9, that's 39. Plus 9, that's 48. Plus 9, that's 57. Plus 9, that's 66. So you separate with what? Comma. 21, 30, 39, 48, 57, 66. And then the way you move this way, subtract 1. So this should be 20. This should be 29, 38, 47. Yes. 56, 65. The last one should be a maximum, which is well, in this case you end at 74. So it is what it is. 65 plus 9, 74. All right, so here we go. 20, 29, 38, 47, 56, 65, 74. And we stop. They wanted 7 classes with stop. So this is it. Remember, you're still increasing by 9 here. Okay, moving on to the next one. So please take notes of 3. Whatever I don't do is what I don't think is important. All right, so number 6 says construct a frequency distribution and a frequency histogram for the data set using the indicated number of classes, etc. So here, I mean, we can quickly locate the frequency histogram, but the classes. So you need to go to Stat Edit and enter this data in your L. So I will show you what I have. And then once you do that, you sort. So I'm going to enter mine in L1 and I'm going to sort L1. And I'll show you just my results. Okay. Let's quickly do that. Second quit. So I'm going to show you what I'm doing right here. So when I go to Stat Sort, my data is already in L1. Second function, L1 is right here. Close parenthesis. Press enter. It's done. So when I go to Stat Edit, here goes my data. It's already sorted. Okay. Please take your time and enter your data. So enter your data into whatever L you wish. Okay. All right. So I know my minimum to be 295. Okay. So that's going to be what I start with. 295. I'm going to start with 295 for sure. And I know my maximum to be 514, I believe. 514, and I have 8 classes. 514. Okay. So my class width is going to be 514 minus 295 divided by 8. And I'm going to round that, remember? 514 minus 295 divided by 8. That's 27.375. We round up 28. So that's going to be my class width. So I'm going to add 295. I'm going in increments of 28. So 295 plus 28, 323. So this has to be 3. You can change this color, 322. All right. So we're going to go in increments of 28. 351, 379, 407 plus 28, 435 plus 28, 463 plus 28, 491. Okay, so you increase by 28 class width. So this guy here, we know it's simply going to be 350 subtract 1, 378 subtract 1, 406 subtract 1, 434 subtract 1, 462 subtract 1, 390. If I do 390 plus 28, I get to, yep. Oh, I made a mistake here. So this is 490 plus 28 gets me to 514. So this is perfect. Now it's a matter of going back to your data and counting. From 395 to 322, what do I have? 1, 2, 3, 4, 5, 6. This should be 6. So you just count. Literally you count. Okay? So going back in your data, and I'm just counting, from 323 to 350, I have 2. 351 to 378, 3. 379, 406, 5. 407 to 434, 7. 435 to 462, 4. 463, 490, 1. 491 to 518, 2. That's that. The histogram data, you could graph it by going to start plot, but you're gonna have to adjust your window, and we did that in class. You're gonna have to adjust your window. Your X minimum, you need to start it somewhere. Okay. Your X minimum could be your 295, or you could go, you can use your class boundaries literally, yeah, or you could go a little lower. Let me think. We could go a little lower. We could do 295 minus 28, so we could go 267. Okay, X maximum, let's take the maximum, which was 514, and add 28, 542. XSCL could be your class width. Your class width is 28. And then your FREC, so Y minimum is going to be 0, Y max can be 8, and you can go in increments of, Here they have 1, 2, 3, 4. So they go in increment of ones, so that's fine. So we're gonna adjust the window like that. 267, 542, just to be as close as possible to what they have on the picture. Y minimum 0, Y max 8, going increments of 1. That's that. So this is a picture of my window. Okay. Take a picture of that, and then I'll show you how we go graph. Remember where your data was. Your data is in L1. So okay. So I'm gonna go to second function, start plot. We want a histogram, so here, okay. And just do L1. I keep this at 1, yeah. I'll graph it, let's see. Okay, it doesn't like what I have, so let me just not have anything in frec, and then let me delete what I have here. Let me just graph it. Okay, it needs frec, it needs frequencies. Okay, let's see. It definitely wants frequencies. It doesn't like the fact that I only have a list. Okay, it rather have, let's see. Wants frequency by all means. Yeah. Well, let me look at the line plot real quick. The line graph should help me. Let's see. I mean, we could literally guess instead of trying to plot and mess up my stat edit. I'm just gonna guess. The first class is a frequency of 6. There goes 6. The second class is a frequency of 2. There goes 2. Third class is a frequency of 3. There goes 3. Oh, here we go. The fourth class is a frequency of 5. There goes 5. Oh, everything is pointing to this graph. The fifth class is a frequency of 7. There goes 7. The other guy is 4 here. The 1 over here. And 2. I think the choice should be A. And I just looked at it. I looked at my frequency table and I matched. So this is 6, 2, etc. So it should be A. I don't need to graph and mess up my data here. It says describe any patterns. So we know the choice is A. Describe any patterns. Choose the correct answer. The class with the greatest frequency, class 5. That's incorrect. Class with the greatest frequency is class 1. That's incorrect. The class with the greatest frequency is class 8. That's incorrect. Let's see. This is the one with the greatest frequency. The class with the greatest frequency is class 5. Should be A. This is correct. Yep, the rest is incorrect. So, mark a very, very good exercise. It shows that you can build a frequency distribution, you can locate a histogram, read the bars, and then you can describe a basic pattern. So I like number 6. Number 9, this is talking about scatter plot. Use a scatter plot to distill the data shown in the table below. Data represent the number of hours works, the hourly ages in dollars of 12 production workers. I already entered mine in the stat edit, so I'll show you. I entered this in L2, L3. So let me show you. We're going to go to second function, start plot, turn it on again. L1, L2. We're going to change this to L2 and L3. And there goes your scatter plot. Once you're here, remember we adjusted the window earlier, so we're not going to do adjust window. We're just going to do zoom start. Okay, doesn't like what I have, so let's go back and let's see if we're missing anything. L2, so it's the same. All right, let's go back. L2, L3, perfect. Let me go to Y, let me clear it, perfect. Okay, making sure I don't have anything. So this is what I have. So I'm gonna go to equal to so We're going to go to let's crop. We can go 'That's going to be over here, sigma 3.0777 over 28.83 times 100. So let's quickly put that in the calculator. 674 divided by 76.083 times 100. Yep, it gives me a 3.4%. Round to one decimal places, 3.4. And then the next guy, 3.0777 divided by 28.833 times 100. 10.7. Here we go. All right. What can you conclude? See, this is the guy with the highest CV, so that's the data that is more dispersed. So ages are more variable, yep, than height. You want to make sure you know how to do this. You want to make sure you know how to do that. for sure. There goes 33. And 37, we're talking about measures of position. You put the data in, you have to put Q1, Q2, Q3. All right, let's quickly do that. Start edit. Put the data in L1. 2141. 6270. 5764. 3 10 7 7 9 7 2 6. All right, let's check the data again, make sure you didn't make a mistake. 750726141. Perfect. Once your data is in, let me show you. You have your data in. Then you go to 1 var start, second quit. Start, 1 var start, L1. Calculate. We just want the measures of position, so the button part. So this is what we want. Perfect. Now that we have everything we need, Q1 is 2. Q2 is median, 5.5. Q3 is 7. Perfect. Your minimum is 0, maximum is 10. And literally, you look at your box plot. You start at 0, 0, which is all good. Now Q1 is 2. 1, 2. This is not it. 1, 2. It's not it. 1, 2. Well, it could be C, but I don't see the rest. So literally, you check the minimum, you check the Q1, all of them. So you A and B wouldn't work. It could be any one of those things, but it's C. I have the key. So make sure you know how to do one of those. 37. Okay. 38 you can do on your own. 39 your own. 75th percentile, you have to look at Q3 and see whatever data falls above that. I'm not doing it. 40, yeah, unusual score, that's the Z score. 41, still the Z score. They gave you different Z score. They want you to find the Z score. Let me give you a hint. In L1, you're going to put 33,000, 37,000, 31,000. And then in L2 is going to be L1 minus the mean, 34,000 divided by 2150. And then you're going to find the Z-score for each. Once you have the Z-score, then you compare. First of all, you enter the Z-scores here. And then you see whichever one falls where. Okay, so now it talks about percentile. Which one is in which percentile? Oh, it's a bell-shaped distribution, so you're going to use the empirical curve. How cute is that? So, if that's the case, you know, I love things like that. So let me do 41. So let's go into L1 quickly, okay? And let's enter the data. So we're going to enter 33,000. I'll show you my screen in a minute. 37,000 and 31,000. In L2, we're going to program it as, let me show you, 2150. Now this beautiful thing is going to be open parenthesis second function L1. minus the mean, which was what, 34,000. Divide that by what? Standard deviation 2150. Okay, press enter. So this is what we have so far. All right, perfect. So now let's go ahead and enter the z-scores. This is number 41. So z-score for this guy is what? Is nearest 100, negative 0.47. The next one is 1.40. The next one is negative 1.40. Perfect. According to the z-score, will the lifespans of any of the type be considered unusual? I have nothing that is outside of negative 2,2. So nothing is unusual really. No z-scores here are outside of negative 2,2. All of them are within the range, so nothing is unusual. Now, it says the lifespans of 3 randomly tired 31,850, 36,150, 34,000. Using the empirical rule, find the percentile. Now, remember the empirical rule, just so we are all on the same page. So let's just throw out the bell curve, just so we are all on the same page. And you could just Google really quickly the empirical rule. I'm gonna Google it, empirical rule. Remember, you don't have to memorize anything, but you do need to remember what is what. No need to memorize, but you need to know where what is what. Let me see if I can blow something up here, such a way that we can all see. Yes, this one right here. Let's take a picture. Perfect. See that? This is the empirical rule. Perfect. Let's crop it. I mean, seriously, when something gets big, it really can get big. Let me erase a little bit of the nonsense here. So this is what I have. My mean is what? 34,000, right? So mu is 34,000. So the mean is 34,000. Like the middle is 34,000. So that is the 50th percentile, isn't it? Should be the 50th percentile. So the 34,000, that's the 50th percentile, is right on 50. Everything below is 50%. So that's the 50th percentile. 31,850. What is that? Let's figure it out, please. Let nobody kill me in this thing. The 31,850. What does that belong to? That's really the question. 36,150. I know that you're going here, here, here. So over here should be mu minus sigma. So let's see, 34,000 minus sigma, which is 2150. That's 31,850. Ooh, 31,850 is right here. This is supposed to be mu minus sigma. And remember, all of this, look at the position. It's right here. So it's this guy. All of this is 13.5. So it is 13 plus 0.5 plus 2.35 plus 15%. So this is 13.5 plus 2.35 plus 0.15. So let's add that up. 13.5 plus 2.35 plus 0.15 is 16. So this is 16%. 16%, perfect. This is 16%. Now 36,150, where does that fall? Okay, Let's see. Let's do 34,000. Let's add the sigma 2150. This guy here is 36,150. So what is remaining here? We're not interested. We're interested more into what is here. So let me put that in blue. We really want to know what's the percentage there. We know we have 16 over here. And then we know in there is 34. This is also what, 34. So that's going to be 34 plus 34 plus 16. 84. Perfect. That's the answer. You really want to make sure that you know how to do 41. Definitely on the quiz, I'll give you something like 41. Because that tap into your z-score, that tap into unusual or usual scores, and that taps into what? The empirical rule. So you want to make sure you know how to do 41. I think this is it. This ends. Yep. I'm done. This is it. So make sure that I'm going to post these notes. I'll post the video as well. Make sure that you know how to do 41. Really comfortable with 41 and all of the other ones that are circle. All right. Good luck on your Chapter 2 quiz.